objective of this practice is to analyze the microstructural changes of the welded steel that has through all the different zones of the welded cord.
The experimental procedure consists first of welding two steel plates with microwire. After they were cut with the disc machine, two samples, one of the welding steel and the other without welding. Then they were mounted on the machine for backlights, and this was done with a procedure of approximately 10 minutes at pressure and temperature with the phenolic resin potware to obtain the backlights from our samples. Samples were made marked with the Dremel, and subsequently the backlights were mounted and leveled and placed in the polishing machine. They were sanded with a force of 18 pounds for 4 minutes at 200 revolutions per minute with the different sandpapers. Later they were polished with the alumina solution to give in the finish that is needed. The two samples were attacked with the nitrile. Finally, we proceed to make the analysis of the samples. The hardness test of beakers was performed on each backlight. Then an analysis was made in the metallographic microscope with the 100 lens to determine the size of the grains to be able to make the necessary calculations. For the results of this practice, we expect that the hardness of the weld steel will increase due the melting of the steel and solidification. Changing its mechanic properties, reducing its grain size, would increase its hardness. In our results, we can realize that the hardness of beakers did increase. However, the grains remain almost the same size. In our samples, we use the metallographic microscope. We can observe the image of seamless steel and weld steel. For the first case, we counted a total of 23 grains, and for the second, a total of 25 grains. The first step to calculate the grain size is to adjust the scale to 100. Then we use the formula n equals 2 at minus 1. The grain size is low case. This gives use a value of 12.16 ASTM. For welded steel, it gives a value of 20.28 ASTM. For this test, we expect a notorious change of grain, but it was not so noticeable. On the other side, for the beakers test, the hardness of two samples was obtained. For the welded steel, a hardness of 188 hardness of beakers was obtained, and for the steel without welding, of 141 hardness of beakers was obtained. This indicates that the welding increased the hardness in our material, which is the behavior we expect.
The main advantages of welding are that first of all it is more economic and also fast. Plus, if it is done correctly, you can get permanent joints with the same hardness and even more than the metal base. And also you can use this type of joining with different types of metals. There are several disadvantages with welding. One is that it results in residual stresses and distortion of the workpiece. Also, there are metallurgical changes because now the structure and the welded joint no longer has the same structure. So it will need a stress relieving and also a heat treatment so it can be the same structure again. And besides, the welding process also gives out and produces like a lot of harmful radiations like light and fumes and also sputter.
Since welding is a hot working, the process makes the structure recrystallize. So it makes the grain smaller and improves the hardness of the material.
The thermal cycle of the welding causes alterations in the material's compositions, in the size and the volumetric fraction of the precipitations by dissolution and growth. These transformations make microscopical changes such as residual tensions, resistance modifications, and fracture toughness. The main reason how it works is the potential difference between the electrode and the metal sample. This potential energy makes the air a conductor, closing the circuit and establishing an electric arc between the sample and the electrode. The arc hits the electrode corner and the metal base partially, making a fusion where the electrode is deposited and it works as a glue between the metals.
The welding process is a really important process since it's really useful in the industry and in many aspects of our lives because we can join different materials, different metals, and also it is really important for us to know that the properties in the part that we just welded are different than the whole material because of the heat, and we will need a heat treatment in order for it to be the same.
In this practice, I realized that by welding a material to another doesn't make the material different. It just refills the zone that was damaged. It doesn't give the spectacular properties, so you have to do heat treatments to make the material has the properties that you want.
For my conclusion, the welding is part of many manufacturing processes today, allowing metal parts to be joined by melting solder with an electrical circuit. The welding compromises the mechanical properties of a material because that is where you can have a failure of a fracture. It is important to know how thermal treatments change the properties of material, and this practice was achieved in a successful way, applying knowledge of application of the materials in more engineering way.
My conclusion to this practice is that welding is a basic tool as engineers. We have to know everything related to it, such as the properties which change when combining metals and adding different temperatures, heating it or cooling it. So knowing all of this can achieve better materials with better mechanical properties. So it's up to us to know all of this to make a better world. The welding process is an effective way of creating metal unions, which are very resistant, ductile, good heat and electrical conductivity, and have many different applications in many different fields. If the engineer knows how to do all of this stuff, if the engineers know how to make it done.